Mr. Wigdahl here with yet another lesson on comparing fractions. Must be pretty important because we have to go over it over and over. Now, let's say you are a really lucky person and you're presented with a math problem that looks like this. And right away you notice, hey, my denominators are the same. This is going to be easy. Now all I have to do is compare the tops, the numerators. And anyone can tell by looking at this. And I mean anyone, like any age. Like I think a 2-year-old could say which is bigger, 1/3 or 2/3. It's like which is bigger, 1 apple or 2 apples. We know that 2 is more than 1. It's so easy. But I'm sorry to tell you, that is not how it's always going to work out. Most of the time, you're going to have unlike denominators, and that's where it gets tricky. You say, which is bigger, 1/4 or 2/7, right? And you're like, oh, brother, I can't compare the denominators, can't compare the numerators. So then we got to go back and remember, how do we make equivalent fractions? It all goes back to equivalent fractions. Doesn't matter if you cross the A or not. It's still going to be equivalent fractions, but I'll go ahead and cross that A. So if I look at 1/4 and 2/7, are 4ths and 7ths equivalent? Obviously, no, they're not. So I have to go, okay, well, fine then, be that way. How do I make them equivalent? Well, remember, I can count by 4s, 8, 12, 16, 20, 24, 28. Ding, ding, ding. If you know your facts, you know that when I hit that one, that should be a 4, 21, 28. I just hit the one that they have in common. Remember, we have to have common denominators, or basically multiples of 4 and 7 that they have in common. They both are factors of 28. So I go over here with a 28, and I go over here with a 28. And you can write this wherever you want. This is just how I do it to kind of make it look nice. How many 4s in 28? 7. 4 times 7. Remember, I'm working backwards here. 4 times 7 equals 28. 1 times 7 equals 7. And then working forwards. How many 7s in 28? Well, I just said it's 4 times 7. So 7 times 4. Then I got to do 2 times 4. Nice multiplication sign, Mr. Wigdahl. 2 times 4 is 8. All right. Now, I'm going to switch to a whole nother color here. Getting wild with the colors. Oh, yeah. 7/28 and 8/28 I can compare because they have the same denominator. And then it goes back to over here. Anyone can tell you that 8/28 is bigger than 7/28. Therefore, I put the less than sign in. Okay, that's confusing. Reading this across, starting from left to right like we do in the Western world, I say 7/28 is less than 8/28, right? Okay, let me see if I can attempt to erase all of that. My guess is I probably can't very easily, but let's see here. Oh, that sort of worked. Sorry, that's going to be a little bit ugly, but we'll go with it. Okay. Let's try another one. And remember, it always goes back to equivalent fractions, right? How about 5/12 and 3/9? I always put that big circle in the middle. And what I mean by that circle is I'm giving you the choice of less than, greater than, or equal to. Okay. So now, are 12ths and 9ths, are those the same denominator? No, obviously. So I got to convert them. And I look at them and I say, ugh, what is 12 and 9 both dividing to? If you know your facts, this is easy. Although, you might not know your 12 facts. Well, you probably do. Going by 12s, I go to 36 right away. And when I get there, I go, oh yeah, 9. I know 9 goes into 36. But if I didn't know, I could start counting. And there they are. Okay, so I'm going to make this 36ths. And I'm going to make this 36ths. And I go, how many 12s in 36? 3. 3 times 5 is 15. How many 9s in 36? 4. 4 times 3 is 12. Now, easy to tell that 1536 is bigger than 1236, so I use greater than symbol. There is one other way, and if you really know your facts, you probably saw this. 3/9 is actually not reduced. Okay? If I reduce this by dividing both the numerator and denominator by 3, 3 divided by 3 is 1, and 9 divided by 3 is 3. Dividing this down to 1/3. Now, I can actually convert 1/3 to 12ths. So I first go down, then I got to go back up. How many 3s in 12? 4. 4 times 1 is 4. 4 12ths. Now remember, I'm comparing 4 12ths to 5 12ths. And I mean, it's still obviously bigger, but I'm just saying that there was that other tricky way, and you would have had to have noticed that 3/9 was not yet reduced. And you might not be on the lookout for that unless you really know your facts. If you saw that when you first looked at 3/9 and realized it was equivalent to 1/3, you should feel really good about yourself as a mathematician. What else do you need to know? Should I do one more? I can do one more. Let's see. This is going to look funny. Sorry about the funniness. Delete. Get the right color. Dump it in. Okay. Let's go back to... Let's do one more. Oh, I don't know. We can... Oh, you know, and I should remind you. You probably knew this, but if you were presented with a problem like this and all it was figure out the equivalent fraction, you just go, how many 5s in 10? 2. 2 times 3 is 6. It's that easy, right? Give you another one. If I said 5/4, 5/4 is 15 what? Put the numerator on top. You had to fill this in. You'd go 5 times what is 15? 5 times 3. 4 times 3 is 12. Those are equivalent. All right, one more comparison. We're going to go with 4/5. I'll put my big missing symbol thing in here. Maybe I'll even fill it in for you to look kind of cool. There we go. Looks a little cooler. 4/5 is greater than, less than, or equal to 20/25. Okay? And I know some of you are looking at that and you instantly see the pattern because you know your facts and you say, oh, Mr. Wigdahl, if I multiply 4 times 5, I get 20. If I multiply 5 times 5, I get 25. Those are equal. Totally. If you didn't see that right away, you'd have to count out. So 5, 10, 15, 20, 25. Oh, goes right into 25. Nice. I don't even have to count out my factors of 20 or my multiples of 25 because they already have those in common. So I only have to convert this one, right? So 5 goes into 25 5 times. 5 times 4 is 20. So there, if I went to the work of it, I would compare this and this, and I got equals. I'm circling this in white right now. Can't you tell? There you go. Okay. Any questions? This is a video, so if you just raised your hand, I don't know how you expect this video to answer your question. Yes, you in the back. What I have one. Thanks for asking. The question was, how many pets do you have? I have one pet. I have a dog. Her name's Annie. She is a lab husky mix. She can catch frisbees in midair. Yeah, it's very amazing. Anyone else have any questions, but pertaining to math, not about my pets? Okay, no questions? Great. If you do have any questions, you're welcome to rewatch this video. Thanks for watching. Have a nice day.